Alright, Bismillahirrahmanirrahim. Assalamualaikum. So in this video, I will show two sample tests for mean with paired sample. Right. In previous video, we already touched on one sample test for proportion, two sample tests for mean with independent samples. In this video, we try to understand how to deal with paired sample, right? So the two sample test for mean with paired sample means that this hypothesis is for testing the difference between two population mean with two sample observation which is independent. They are not independent anymore, they are dependent. Dependent means that the two dataset value are collected from the same element or same sample, right? Same observation. So in paired samples, the difference between observation on each matched pair is denoted as D. This is a different, we want to measure the difference of each value between two value. This is what we call as paired difference. So in paired sample hypothesis testing, the sample statistic D bar is used for inference of mu D, where the D bar is the mean of paired difference. Means that once you already calculate the difference of each data, then we will calculate the mean of the difference. So for mu D is the mean of paired difference for the population. So the null hypothesis for this paired sample t-test is when the null hypothesis is mu D is always equal to 0. And the alternative can be either not equal to 0 or more than 0 or less than 0. Alright. For the alternative hypothesis, not equal to, this is meant for two-tail test. For alternate hypothesis, more than, this is a one-tail test, but this is for a right tail. For less than, this is also equal to a one-tail test, but this is for left tail. Right, there is a data analysis tool in Excel analysis which is can help us to calculate the paired sample t-test using Excel. Very easy. Right, so let's look at example number 5. In example number 5, order picking is a process of in the warehouse supply chain process. It is a labor-intensive, expensive process for every warehouse. The manager of the warehouse tends to improve the picking rate to increase the efficiency of the warehouse performance with no change in the labor. So the Excel file order fulfillment picking process change, which is I already upload it into a discussion group. So you can download the Excel file. So it contains the picking rate of by warehouse order fulfillment worker before and after the improvement of the order picking process. So the question is, does the new picking process improve the picking rate of the pickers? So now, first step in hypothesis testing, we need to write down hypothesis statement. So our hypothesis statement, null hypothesis, mu D is equal to 0. The alternative hypothesis, since we want to know the improvement of the new picking process, so mu D is more than 0. So this is what the null hypothesis or alternative hypothesis that we want to measure, right? So now, our alpha here we set is equal to 0.05. The next step is our test statistic. So our test statistic, since we are dealing with paired sample, with two sample with paired sample, so we are using t-test. So t-test, So let's look at the data set. So we have order fulfillment picking process change. So we have before and after. So now to calculate the pet sample t-test, we just go to data tab. Alright, we need to click on data analysis and find t-test pet2 sample for mean, and then click OK. And then for variable 1 range, we need to select value for before picking process. And for variable 2 range, we need to highlight for after column, only highlight the numbers. And then hypothesize mean difference should always equal to 0 because the null hypothesis is equal to 0. And we let alpha equal to 0.05, and I want Excel to display on the same worksheet. So I select here, I want Excel to display the result here, and click OK. So now Excel is already give us the value of statistics. So variable 1 means that this is for before and this is for after, right? After. Okay. So now we already have the value mean for after and before and after, variance for before and after. Observation, we have equal observation 12 and 12. Pearson correlation, this is the value that we measure the relationship, but I'm not going to explain here. We will look on the next chapter. So the degree of freedom is equal to 11, right? And then the t statistics is equal to negative 8.5123. So the t statistics is equal to negative 8.513, right? So now next step is we need to find a critical region, right? The critical region. So by looking at the alternative hypothesis, we know that the mu d is more than 0, means that this is a one-tail test. So the rejection region should be on the right hand side, right? So this is the 0 value. This is the rejection region. This is a rejection region, and this is acceptance region, right? So what is the value of this region and critical value? So we need to go back and see the Excel result. Now we look at the T critical one-tail test. So this is 1.79. So the critical value is 1.79, right? So next step is we need to make our decision rule. So our decision rule, if T calculated is more than T statistics. So in this area and in this term, the test statistic is T calculated, right? And then this is the value of T statistic. Right? If T calculated is more than T statistic, then null hypothesis is rejected. So means that if the value of T calculated lies under rejection region, then we will reject null hypothesis. If the T calculated lies before the rejection region, then it means that it fall under acceptance region, we will accept null hypothesis. So a decision is, since T calculated is equal to negative 8.512, means that less than T statistic. So means that null hypothesis is accepted. Means that our conclusion would say, since we are accepting null hypothesis, So it means that there are no difference between before and after process, picking process. So we can conclude that there are no difference on before and after picking process. Right. So I think that's all. Thank you very much. Assalamualaikum.